We're talking about multiplying fractions again, and this time we're going to be multiplying fractions by fractions, which is an interesting concept for sure. And I think a real life application is really kind of demonstrated by this model right here. So, what if, let's just say, I have a candy bar and there's 2/3 of it left, right? And then someone says, well, what would of those 2/3 pieces of a candy bar that you have left, what if we say we want 3/4 of that? And when I hear the word of course, my brain starts thinking about multiplication. So what I would do is I would say, all right, well, then why don't we take this 2/3 times the 3/4? And if we're using this model, we're just going to kind of put the two pieces together and then take a look at where both the blue and the red pieces overlap. So we have 1, 2, 3, 4, 5, 6 pieces, 6/12, because there's 12 boxes all total. We would have 6/12 of that candy bar left. And I could even reduce that to the 1/2, right? So, okay, that's just a practical use. But beyond that, I really want to give you a firm understanding of what to do when you multiply a fraction. Here's a great example. I have 1/5, and I'm going to multiply that by 1/6. I literally multiplied just straight across from here to here. So 1 times 1, we're putting the numerators together, is 1. And 5 times 6 would be 30. That's it. I'm done. I know that 1 in 30 in its least common form. In case you forgot how to do that, go back and take a look at your fractions notes. We did that a long time ago. But I know, first of all, 1 is as low as it can get. So that's a great indicator that this fraction, this 1/30th, is in its lowest possible form. Okay, so that's the easiest possible way to kind of look at multiplication of fractions. Here's one, 3/7 times 2/9, that I can actually do a little prep work to make things a little easier on me. I just need to know my factors. In other words, my times tables, and I'll show you how. First of all, I am going to look kind of corner to corner here, guy, as if I was Shetlerizing, and see, let's just start with this denominator and this numerator up here. Do 2 and 7, 2 and 7. Do they have any common factors other than 1? And they don't. So we're going to let that alone. How about this? 3 and 9. Do they have any common factors? And yes, they do. 3 is the greatest common factor. So this is what I'm going to do. I'm going to say, okay, I'm going to get rid of this 3. What is 3 divided by 3? It is 1. And then related down here, I'm going to get rid of that 9. And staying with my theme of divided by 3, what is 9 divided by 3? Well, it's 3. I just simplified my problem here a little bit, didn't I? Okay, so now let's go back to what we did in the last slide. We're just going to multiply straight across. 1 times 2 is 2, and 7 times 3 is 21. Is that in its least common form? I think it is. I can't think of any common factors other than 1 between 2 and 21. Let's do another one just to be sure we're good with this. All right, so I have 8/9 times 1/2. I'm going to, first of all, look catty corner here. Ooh, I see one couple that makes sense, but the other one doesn't. All right, let's take a look. Do 1 and 9 have any common factors other than 1? No, 1 is its least common form, so nothing to do there. However, when I look at 2 and 8, and I know the factors of 2 and 8, the greatest common factor of both of those is 2. Also, they're both even numbers, which tells me they're both divisible by 2. So I'm going to get rid of these. I'm going to reduce them. Cross reduce them is actually what it's called. Okay, how many times does 2 divide into 2? Well, 1 time, because 2 divided by 2 is 1. And then up here, same thing. 8 divided by 2 is 4. So I simplified. I can multiply straight across. We have 4 times 1, which is 4. And 9 times 1, which is 9. Got to ask myself, for 4/9, can I reduce this? I don't think so. There are no common factors of 4 and 9 other than 1. One more example. Promise I'll let you go. This one's a little tiny bit more complicated. It's adding another step. Multiplying two fractions. Just like the last two, I'm going to see if I can cross-reduce. Let's take a look. Do 5 and 11, because I'm going catty corner here. Do 5 and 11 have any common factors other than 1? No, they don't. Can't do anything there. How about 3 and 9? Do they have any common factors? Yes, they do. The greatest common factor is 3. So I'm going to be able to get rid of that one. I'm going to be able to get rid of that one. So let me think about this. Greatest common factor of 3 is 3. 3 divided by 3 would be 1. I just reduced that. And then I'm going to do the same thing to my 9 down here. 9 divided by 3 is 3. Now I just go ahead. Whoop, I don't need that. Here. I am going to cross multiply. Oh, pardon me. I'm going to just multiply straight across. 1 times 5 is 5. And 11 times 3 is 33. Any common factors of 5 and 33? I think not. Now, I know I said I was only going to show you one more, but let me think a minute. Do I have, oh, yes, this one's a little bit more complicated, and I want to show everybody the work. Well, first things first, there's a lot of work that's already done. Let me erase some things here so we don't get too confused. It's like there was a elf on the shelf taking care of some of my work for me already. Let's get rid of some of these numbers just so we don't complicate things. We're eventually going to end up with 1/10. So why don't we just stay with the 1/10, and I'll show you why 6/12 times 2/10 equals 1/10. Right. We are going to cross reduce. Let's take a look. Catty corner here. 2 and 12. Do they have any common factors? They absolutely do. 2 is the greatest common factor of 2 and 12. I am going to be getting rid of this 2. I am going to be getting rid of this 12. So now I got to think about up here. If the greatest common factor is 2, 2 divided by 2 would be 1. Likewise, down here, the greatest common factor of 12 and 2 is 2. So 12 divided by 2 is 6. I just cross-reduced one set. Now, here's another set. 6 and 10. Do they have any common factors? Well, yes, they do. They're both even numbers, which tells me they're both divisible by 2. So 6 divided by 2, let's get rid of that, is 3. And 10 divided by 2, get rid of that, is 5. Right. It cross-reduced everything that time, which was kind of nice. It makes things super simple. So 3 times 1 is 3. And 6 times 5 is 30. Now, when I look at this fraction here at the end, 3/30ths, do 3 and 30 have any common factors? And yes, they do. 3. So I can divide both the top and the bottom. I'll buy a little 3. I don't know why it's so little. Let's make it bigger. It's hard. Grow, little 3, grow. There we go. It's better. So we're saying 3 divided by 3 is 1, and 30 divided by 3 is 10. There, I just reduced a fraction to its common form. Ladies and gentlemen, that is multiplying fractions, and we went through a couple examples. Even the last one we did, probably the hardest one we showed you. That's the math you should know. Thanks so much for tuning in.